In this video, we'll talk about macros and how they can be used in ABAP code. Macros really are a list of statements that can be reused within an ABAP program. Macros will be converted to the actual ABAP code just before compilation, so they're not interpreted in runtime. As a consequence, macros have no context or scope of their own and inherit the scope of where they are called from, because before compilation, the code block represented by the macro will be just put in the ABAP code that you have written as if you had actually written the code wherever you call the macro. This has the advantage that the syntax checker will be able to check the syntax of the macro, whereas you would use another dynamic programming technique that might not be the case. You might run into runtime errors, but it also has a disadvantage. Macros cannot be debugged, and the debugger will step over macros as if they are one single statement. So you should be careful when you use macros and only use them for specific purposes and only use very simple macros. What are we using macros for? Well, they can be used to make code a lot more readable and to avoid boilerplate code or repetitive code. They should be used with caution, as I said, and having long macros with complex structures and complex logic should be avoided. To make it clear when you're using a macro, it's considered best practice to use a clear naming standard so macros can be easily distinguished from normal ABAP keywords. In this course, all macro names will be prefixed with an underscore so they're easily recognizable. Macros use ordered parameters that are referenced by numbers. There's a maximum of 9 placeholders that you can use in one single macro. These parameters can be variables, variable names, parts of variable names, ABAP statements, even parts of ABAP statements. So you can make it as complex or as simple as you want. It's a very powerful feature, but you should be careful not to use it as a replacement for other modularization techniques like forms, methods, function modules. It's only to make your code more readable and for very simple things. So let's have a look at a few examples. First example we'll look at is a very simple macro. It's just going to print some data, 3 variables on the screen. So a macro is always between the define keyword, then the name of the macro. As you can see, we always use an underscore here, and the end is signified by end of definition with dashes between the words. You can only, you have to define a macro above the area where you want to use it. So it's not that if you define like a form, for example, you can define a form in a different include even or below where you first call it, because it will all be loaded into memory. But with macros that doesn't work. The macro has to be defined above the first time you use it in your code. So how do you use a macro? You simply write the name of the macro as we have here, and then you put the variables in the correct order behind it. And so the first variable will be referenced by &1, second &2, the third &3. So when we, this is just a single usage, so we call the macro with these 3 variables. You can also use the colon comma notation where we say we're going to call the macro with this set of variables, and then we put a comma. We're going to call the macro again with this set of variables, another comma, and we call the macro again with this set of variables. So the equivalent of this statement would be these 3 statements. Now in this case it's almost the same amount of code, but here we're just showing how this works. So I did mention the debugging part, so I cannot put a breakpoint inside a macro. That's just not possible. And if I put a breakpoint here, we'll see that this, when I want to step into it, it's considered one single statement, so I can only step over, I cannot step into it. The output would be, this is the first occurrence, then we have the 3 lines that we have with the colon comma notation, and then 3 lines that we have just with the regular write statement. So this is very basic macro, just to explain how it works. In the introduction, I did mention something about scope, and that a macro has no scope of its own. So when we're calling a macro, it will inherit the scope of the location where we're calling it. So here we have a form. The form is a multiplication table, and there's a variable inside this form. And we can see that in the macro we can use this variable because it inherits the scope of where it is called from. Now, if we would create another form, and call the macro from there as well, this variable is not in the scope here, so on compile time or on syntax check time, it already knows that this is not going to work, because a macro is simply a replacement of code before compile time. So since the variable used in the macro is not in scope of this form will not compile. So let's have a look at what's happening here. We have a macro that simply does a multiplication. So it will put the result of a multiplication of the first and second parameter in the variable lResult. We're going to print the multiplication tables from 1 to 10. So we're going to do this 10 times. We write a header, what's the multiplication table of a specific number, 1 to 10. And then we're going to call the form multiplication table. In that form, we again 10 times call this multiply macro with the two factors in the multiplication, and then we write the output. So let's first have a look at what that looks like. So we have the multiplication table of 1, 2, 3, 4, etc. Printed on the screen. Very simple. Now let's step through this in debugging, and so we can see how a macro behaves. So in our starter selection code, we're going to call a form multiplication table, and here we can step into the form using the debugger. Then we have our two numbers, index and factor. In this case, they're both 1. Now, in our macro, we cannot step into the macro, so again, we'll step over it in debugging, and now the macro will have put in the lResult value the result of this multiplication. So 1 times 2 is 2. So macro has no scope of its own, and it inherits the scope of where it is called from. So not the global scope of the report, but the scope it is called from. A variable that only exists inside this form can be accessed by a macro called from this form. Okay. Now, how can we use macros? Let's look at an example here. It's an example where we use a macro to get a random date. If you ever need a random number or a random date, there's a few statements that you need to call to actually get a random number. And because getting a random number is something significantly simple, we want to write a macro to do this. So in order to get a random number, we use the CL ABAP random class. And if we want to use it, we first have to instantiate it, and then we can get random numbers from it. So we create a few macros here. The first one is init R&D. It's going to initialize that object. So we create a global object here that's in a global object for our report, and the init R&D macro will check if that is already initialized, and if it's not, it will initialize it. We will call that inside our other macro random date. We'll call it here, and it will check if it's already initialized, so we don't have to worry about that anymore in our code. And then we're going to get this macro will get a random date between two dates. Now we don't want to worry about whether the first date is before or after the second date, so we put a check in there to calculate how many days difference there is between the two dates. So if the second date is higher, then if the first date is after the second date, then we subtract the second date from the first date, and we have the number of days between them. If not, we do it the other way around. Then we get the number of days between those two, give that as a range for getting a integer. So we get a number of days, a random number between the first date and the last date. And then we want to return a date. We convert that number to a date. So we say we first figure out again which was the first date of the 2 days provided, and we add the number of days to that first date, and that will go into our third parameter. So then all of this code, instead of having to call it multiple times, we can just say we want 10 random dates. We just call the random date macro with a start date, an end date, and then we get a random date into this third parameter. So let's have a quick look at what that looks like. So we get 10 random dates. Now, why would we want to use a macro for that? If we don't use a macro, then our code would look like this. And it's very hard to see what the purpose of this code is, because basically all we want to do is get 10 random dates. And so if someone would have to read this code afterwards, they'd have to try to figure out what's going on here, why is this if there, what is it doing, all of that, to just figure out that it's writing a random date. While if you're reading this code, it's very easy to understand. It says here it's going to do something 10 times, and what is it going to do? It's going to get a random date, and then it's going to write it. So this code is a lot more readable than this code, and eventually it's the same thing. So in this case, using a macro would be a great idea to improve readability. Now, as I said before, we can use the colon comma method in our macros, and that could make things a lot easier to read again and also to write. So what we have here is a database table, flight M, that contains flight master data, and that table has a number of fields. Let's have a look at them. So it has ID, D city, A city, D time, etc. So these are the field names. Now, if we have a structure that we want to put this data in, and that structure has the same fields, then that's pretty simple. We can use a move corresponding statement. So if we would want to move the data from this table with the structure of the database table to this structure which has less fields but they have the same name, we could just use move corresponding. But sometimes you want to move data from one structure to another, but field names are not exactly the same, and that's signified here. So we have, instead of ID here, we have flight underscore ID. Instead of D city, we have departure underscore city, etc. So if we want to move the data from the one structure to the other, that would mean that we'd have to loop, and then we have to assign one by one the fields to each other. And that's again not very readable code. Now, if we create a macro, just call in this case the macro simple name move, then we could rewrite the code to make it a lot more readable. So what we say is we're going to move data from this structure to this structure. So the first two parameters are just passed to the macro. Then we put a colon here, and then we're going to use these first two parameters and have multiple calls where these two parameters are the same, but the other two parameters are different. So we say we're going to move from this structure to this structure, and we're going to move the ID field of this structure to the flight ID field of this structure, the D city field of this structure to the departure underscore city field of this structure. So our macro is very simple. So 2 is this target structure, 4 is the target field, 1 is the source structure, and 3 is the source field. So here, with just one simple statement, we can very easily understand what we're doing. We're moving from this structure to this structure, and this field will be mapped to this field will be mapped to this field. So that makes the code a lot more readable, and also allows us to only have one call. We only have to mention the structures once, and then we mention just the fields and their mapping. Now, you can also do a partial field name substitution, because a macro will just be translated to source code, and it will just replace the parameters in the code that it generates. So we have two city fields. We have a departure city and an arrival city. So we can create a macro that says set city, and then we just create a partial variable name parameter. So it says here n2 underscore city. So n2 will be replaced by our parameter. So we say we're going to set the cities for our structure ls underscore flight underscore b. We're going to set arrival city to New York and the departure city to Chicago. So this will be replaced by arrival underscore city and departure underscore city. So that's also very helpful that we can use partial variable names to assign values. Then we just simply write that so we can see that it worked. We can even use ABAP statements as parameters to macros. This is not the greatest idea, but I just want to show it to you that it works. So we only have a macro here that is called underscore calculate, and it just has 4 parameters. And then we write the parameter. Now we put the variables that are changing the least always at the front. So in this case, we're going to call this for the first parameter is the same for all of these calls. So this is the first parameter, although in the code it's used the last, but it's still a good idea to put it first, because then we can say we're going to do a calculation on the lResult parameter, and we're going to first add 5 to it, and then we're going to subtract 1 from it. So here the first parameter is always lResult, so that's the target here, and add is the second parameter. So here this will be replaced by add, this will be replaced by this will be replaced by add, this will be replaced by the fourth parameter, which is the number we're adding. 2 is the keyword that we will put here, and 1 is the target, which is lResult. Here again, subtract 1 from lResult, and then we write lResult. So if we run this, a few things will happen. It will print New York and Chicago, because those are the values we set for that variable. And here we will print first 5 and then 4. For New York, Chicago. So we can use comma colon notation like we did here. We can use partial field names in a macro, and we can even use ABAP keywords inside a macro. Now, this is all pretty theoretical so far, so let's look at a usage example that really makes sense. So here I created a report that basically will again select the data from the flights table and display that data in an ALV grid. Now when you create an ALV grid, you always have to create a field catalog and a sort table. So when we prepare a field catalog, usually that code looks something like this. So first we create a field catalog based on the data definition, so we can just call this function module field catalog merge to get the field catalog in our internal table, and then we start making changes to it. So we read the necessary record from the table for our ID field, and then we change 2 fields here with their respective values. Then we read the next one, and again we change the values. Now the significant parts are always here, and then which fields we're putting which values. So it's very hard to figure out exactly what is happening in this whole code block. So for that we can create a simple macro, and in this form we created a macro to adjust an ALV column. So the macro is called underscore adjust ALV column. It's going to do the same thing. It's going to read from the field catalog table, and it's going to read a specific field name, and then it's going to assign a value to a specific field. And both the value and the field are parameters from the macro. So what would that look like if we want to really use it? So this whole block of code we can replace by this one. And this is very understandable. Here we say we're going to adjust the ALV column ID, and we're going to set the key column to blank and the column text to flight ID. Then we're going to adjust the destination city, we're going to set the hotspot field to X and the column text to departing from, etc. So this is a lot more readable. It's not only less code, but it's also a lot more readable, and it's clear what the purpose is. We're adjusting ALV columns. This is the column, and these are the fields we're adjusting. So a lot more readable. We do the same thing for the sorting. So we create a macro called ALV sort, and we just say we're going to add to the sort position and then set the sort field to the field that we specify as parameter 1. In this case, we only do ascending sorting. If you want to do ascending and descending sorting, you can use also a parameter for this variable. And then we're going to append the sort column to the sort table. So the prepare sorting table would look like this without a macro. Again, that's not terrible to read, but we can replace that with a simple call to the macro, and then it would look like this. So then we just say we sort ALV columns dcity, acd, time, price. So very simple, very clear what this is doing. Now let's call it and see what the result is, although that's not the scope of this exercise. So we have an ALV grid. This field has a hotspot. We change the label and we unset the key flag for this field, and we set these two fields as checkboxes, and we change some more labels. So using macros in this case makes the code a lot more readable, a lot easier to maintain, and this will really help you if someone else to modify this form later. It will be a lot easier to do, a lot easier to understand what's going on. So that's the power of macros in ABAP code.